It was 1895, and Röntgen was experimenting with cathode ray tubes. Suddenly, he noticed a strange fluorescence on a screen across the room. Astonished, he held his hand in the beam. On the screen appeared the silhouette of his bones. Röntgen had discovered a new kind of light, a light that could see through flesh and reveal the skeleton within. This was the birth of the X-ray, a discovery that would revolutionize medicine and science. What if you could see inside the human body without cutting it open? Today, X-ray machines make that fantasy a reality. In this documentary, we'll explore how X-ray machines work, what makes them tick, and how they see into the body. We'll also look at their dangers and myth-busting truths. We'll compare old X-ray machines with the modern ones. Finally, we'll peek into the future. But first, let's understand the magic behind the machine. Today's X-ray machines combine high-precision parts. At the core is the X-ray tube, a sealed vacuum containing a cathode and an anode. The cathode emits electrons when heated, and a high-voltage generator fires these electrons toward the anode. When these high-speed electrons smash into the target, X-ray photons are produced. Surrounding the tube is a heavy lead shield to absorb unwanted radiation. Attached to the tube is the collimator, an adjustable set of shutters that narrows and directs the X-ray beam. The technician operates a control panel to set the X-ray dose. By adjusting the voltage and current, the operator controls how many X-rays are produced and how penetrating they are. Opposite the X-ray tube sits the image detector. Modern systems use digital detectors that convert incoming X-ray photons into electrical signals. A computer processes these signals into the image. In summary, a typical X-ray machine includes an X-ray tube, a high-voltage power supply, a collimator, a patient table, an image detector, and lead shielding. Each plays a vital role. At its heart, X-ray technology is physics. X-rays are light waves, just like visible light, but with thousands of times higher energy. This comes from their incredibly short wavelength. Inside the tube, electrons slam into a metal target. When they suddenly slow down, they emit X-ray photons. Physicists call this process Bremsstrahlung, or breaking radiation. These photons penetrate materials. Denser materials like bone absorb more X-rays. Soft tissues let more through. Air-filled spaces let almost all X-rays pass. On the detector, places blocked by bone show up white, while areas that let X-rays through appear darker. This creates the familiar black and white picture of your insides. Imagine shining a flashlight through a skull. Bone blocks the light, casting a shadow. X-rays work similarly, but with invisible high-energy light. Take a standard chest X-ray. Your rib cage appears bright white, your heart is gray, and your lungs look almost black. Doctors interpret these contrasts to diagnose issues. X-rays are ionizing radiation, so doses are kept very low. Technicians use safety measures like lead aprons and glass screens. Importantly, you do not become radioactive after an X-ray. A chest X-ray exposes you to about the same radiation as 10 days of normal life. The risk is tiny compared to the diagnostic benefits. X-ray technology has transformed from bulky film-based machines to compact digital systems. Modern detectors are like advanced camera sensors, giving instant results. Today's X-rays are faster, safer, and clearer. From medicine to airport security, they help us see the unseen in seconds.
Dentists use miniature X-ray devices to spot cavities under the enamel and check tooth roots. Mammography uses a special low-dose X-ray to detect early breast cancer. Even dental panoramic and CT scans rely on X-ray imaging. Outside medicine, X-ray technology is just as vital. Every luggage scanner at airports and train stations is essentially an X-ray system, looking inside bags to keep travel safe. In industry, X-rays are used for non-destructive testing. They reveal cracks in airplane wings, faults in welds, or flaws in machinery without dismantling anything. Scientists and archaeologists X-ray artwork, fossils, and mummies to uncover hidden details without opening priceless objects. In research labs, X-ray crystallography is crucial. It uses X-ray diffraction to determine the atomic structure of proteins, minerals, and chemicals. And on a grand scale, space telescopes like Chandra observe cosmic X-rays from exploding stars and black holes. revealing secrets of the universe. Clearly, X-ray vision has a role far beyond the doctor's office, making it one of humanity's most versatile tools. Even with all this, myths linger about X-rays. Let's clear up a few. Myth: after an X-ray, you stay radioactive. This is false. X-ray machines do not leave any radiation in your body. Once the X-ray beam is turned off, you're not glowing or dangerous to others. Myth: just one X-ray will give you cancer. In reality, a single standard X-ray gives such a tiny dose that the increased risk is essentially zero. In fact, the increase in lifetime cancer risk from one chest X-ray is on the order of 0.001%. Myth: airport scanners and hospital X-ray machines are equally risky. Actually, airport scanners use extremely low-energy X-rays or millimeter waves and very short exposures. They are considered safe for travelers. Myth: if you get multiple X-rays, it's as bad as radiation therapy. Not true. Even several medical X-rays add up to much less radiation than many natural sources or radiation therapy doses. The truth is, modern X-ray imaging is highly regulated. Every X-ray exam is justified by need, and shields and protocols minimize exposure. If your doctor orders an X-ray, it's because the benefit of seeing inside your body far outweighs the minuscule risk. Don't let myths scare you. X-ray technology has been studied for decades, and safety measures make its use routine in hospitals worldwide. What does the future hold for X-ray machines? The technology keeps evolving. One exciting development is photon counting detectors. These can measure each X-ray photon's energy, giving much clearer images and often at even lower doses. We're also seeing smart AI integration. Future X-ray systems may instantly analyze scans with artificial intelligence, helping doctors diagnose faster and with higher accuracy. Portable X-ray devices continue to shrink. Imagine taking high-quality X-rays in remote clinics or even disaster zones with a tablet-sized machine. New imaging techniques are emerging too. Phase contrast and dual-energy X-rays can reveal details unseen by conventional X-rays, for example, distinguishing tissues or seeing through metal. Meanwhile, combinations like Peru time/central time or X-ray fluorescence spectroscopy are blurring the line between X-rays and other imaging modalities. In short, expect X-ray technology to become faster, safer, and more powerful. The core magic of seeing the invisible remains, but with enhanced clarity and capability. As we innovate, X-rays will continue to help doctors, engineers, and scientists uncover secrets of the human body and the universe. The invisible light that Röntgen first observed in 1895 is still shining on our future. From Röntgen's first discovery of mysterious rays to every modern hospital ward and laboratory, X-ray machines have opened a window into the invisible. They have taken us from guesswork to clarity, from mystery to knowledge. Each X-ray image is a testament to human curiosity and ingenuity. Remember, the next time you see your own skeleton on a screen or watch a technician at work, you are witnessing the power to see the unseen. In the history of science, few tools have been as transformative as the X-ray. It has saved countless lives and will continue to do so. It reminds us that with the right technology, even the deepest secrets can come to light. So as we end our journey, know this: the X-ray machine may be an ordinary part of medicine today, but in its light we glimpse the extraordinary. The invisible light that first lit up Röntgen's lab is still lighting our way. And that's the powerful legacy of the X-ray machine.